Let's start with our first example. We're going to be comparing square root of 3 times square root of 5 and square root of 6 times square root of 2. Notice the square root of 5 and the square root of 2 are already inside a square root. So there's the outside square root and the inside square root. So the way to approach this problem is to square both sides to get rid of the square root. So the outside square root cancels out with a square to get 3 square root 5. And the same thing with the right, 6 square root 2. I still have a square root for both of these, so I'm going to square it one more time. This 2 distributes to both the 3 and the 5, the square root 5. So 3 squared is 9, times square root of 5 squared is 5. And then same thing with this other 2. This 2, this exponent, goes on 6 and square root 2. 6 squared is 36, square root of 2 squared is 2. 9 times 5 is 45. 36 times 2 is 72. So 72 is bigger than 45. So we say that the square root of 3 times square root of 5 is less than square root of 6 times the square root of 2. Let's take a look at a similar problem. We have the square root of 3 times the cube root of 5 and the cube root of 6 times the square root of 2. This problem is a little different because notice the radicals are different. We have a square root on the left and a cube root on the right. Now the way to approach this is to think of a power as the least common multiple of 2 and 3. So we're going to be looking at the least common multiple of 2 and 3. And that's just going to be 6. So we're going to raise both sides to the 6th power. Okay, so we have a square root raised to the 6th power. We can think of a square root as 1/2. So let's rewrite this as 3 times cube root of 5, all under the square root, which we can write it as 1/2, and then raise it to the 6th power. And similarly, we could do the same thing here. We have 6 square root 2, raise it to the 1/3 power because it's cube root, and then we can raise it to the 6th power. We have an exponent to an exponent, so in that case we just multiply the exponents. So let's say we have 3 times cube root of 5, and then we have the exponent of 1/2 times 6, which is 3. On the right, we're left with 6 square root 2, and then 1/3 times 6, which is 2. I'm going to distribute out the cube to 3 and cube root of 5. So 3 cubed is 27. The cube root and the cube are going to cancel, so 5 is going to be by itself. And then we're going to distribute the square here, so 6 squared and root 2 squared. 6 squared is 36. Root 2 squared is 2. So 27 times 5 is 135. 36 times 2 is 72. We have 135 is greater than 72. So we follow up along here and we say that the square root of 3 cube root of 5 is greater than the cube root of 6 times square root of 2. So again, the key to this problem was because they had different roots, we had to raise it to the least common multiple exponent. So the least common multiple between 2 and 3 was 6. Okay, let's look at another problem. We have 2 to the 500th power and 3 to the 300th power. We want to see which one of these is bigger. Just by looking at it, it's not very obvious which one it is. So why don't we take the 100th root to both sides? So let's raise it to the 1 over 100 power. We have exponent to an exponent. So 500 times 1 over 100 will be 5. And then 3 to 300 times 1 over 100 is 3. 2 to the 5th is 32. 3 cubed is 27. We know that 32 is bigger than 27. So we go back up here and say 2 to the 500th must be bigger than 3 to the 300th. Now let's take a look at a more challenging one. What if the exponents are not as nice? What if we have 2 to the 81st power and 3 to the 49th power? The key to this problem is to look at exponents that are near 81 and 49 that make the math work nicely. So let's consider 2 to the 80th. When we look at 2 to the 80th, we're actually making our number smaller. We're really dividing by 2. And let's look at 3 to the 50th. We're making this number bigger by multiplying by 3. Okay, now the 80 and 50 have a common factor of 10. So why don't we raise both sides to the 1/10th power? Eighty times 1 over 10 is just 8. 50 raised to the 1 over 10th, that's just 5. 2 to the 8th, well, we can write it as 2 to the 4th squared. And 3 to the 5th, well, we can say that's 3 squared times 3. 2 to the 4th, well, that's 2 squared, so that would be 16 squared. 3 squared is 9 squared times 3. 16 squared is 256. 9 squared is 81 times 3 is 243. We know that 256 is bigger than 243. So we go back along here and we can plug it in. Notice we made 2 to the 81st power smaller by dividing by 2. Yet we were still bigger at the end, despite multiplying 3 to the 49th by 3 to get to the 3 to the 50th power. So in this case, we can confidently say that 2 to the 81st is greater than 3 to the 49th. Okay, last problem here. This one is even more challenging because we have 2 to the 845th power and 5 to the 362nd power. The idea is similar here. We want to get to exponents that are much friendlier to work with. It is not obvious to see which exponent we should work with, so why don't we look at the first two numbers actually. So let's look at 84 and 36. What common factors, or what is the greatest common factor of 84 and 36? Turns out it's 12. So let's get rid of the 5 and put that as a 0. So let's look at 840, and let's get rid of the 2 and look at 360. And now let's raise both sides by 1 over 120th, since that would be the greatest common factor there. 840 times 1 over 120 is 7. 360 times 1 over 120 is 3. To the 7th, well, that will be 2 to the 6th times 2. And 5 cubed is 5 squared times 5. So let's see, 2 to the 6th, that's 2 cubed, 8 squared, 64, times 2 is 128. And then 5 squared is 25, times 5 is 125. We know that 128 is greater than 125, so we move along here. And notice, 2 to the 845th power is much bigger than 2 to the 840th power. So we went down to a smaller number by actually a factor of 2 to the 5th, which is 32. And then here, we went from 5 to the 362nd power to 5 to the 360th power. So we went down by 5 squared, which is 25. So we ended up going even smaller on the left side here, yet we still ended up with a bigger number. So we can conclude that 2 to the 845th power is greater than 5 to the 362nd power.